Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network, and today I'm going to solve some past paper questions from the topic Integration A-Level Mathematics P3 Cambridge 9709. Okay, so first of all, we have handout question number 13, which is October-November 2010, paper 32, meaning paper 3, variant 2, question number 5. So we have an integral in terms of x, which is x square upon under root of 4 minus x square with respect to x with upper limit 1 and lower limit 0. So the requirement of part 1 is that using the substitution x is equals to 2 sine theta, show that this integral can be converted in this form in terms of theta, that the integration of 4 sine square theta with respect to theta with the upper limit pi over 6 and the lower limit 0. And then in part 2, we need to evaluate the exact value of this definite integral. Okay, so first thing first, what we have is the substitution x is equals to 2 sine theta. Okay, and we need to convert this integral in terms of theta. So this essentially means that in place of dx, we need some expression in terms of d theta. Okay, so for that purpose, we are going to use this substitution x is equals to 2 sine theta, and we are going to differentiate it. Okay, so when x is equals to 2 sine theta, I'm going to say that dx over d theta is equals to 2 cos theta. So x is differentiated with respect to theta. So this means that when dx is made the subject of this equation, so dx is equals to 2 cos theta multiplied by d theta. All right, so in place of dx, we can write 2 cos theta multiplied by d theta. All right, and now we are going to find the new limits. Okay, since as we can see that the upper limit is 1 and the lower limit is 0. These are for x. So we need the upper limits and lower limits for theta as well. All right, and for that purpose, we are going to use the substitution. Okay, so x is equals to 2 sine theta, meaning when x is equals to 1, so we need to find the value of theta. So sine theta is basically equals to half. So theta will be sine inverse half. So sine inverse half is basically in radians, we will have pi over 6 radians. So theta will be pi over 6, as simple as that. And then uh, in place of x, we are going to write 0. So this will be equal to 2 sine theta, which means that sine theta is equal to 0 over 2, which means it is equal to 0. So when sine theta is equal to 0, so theta is either equal to 0, pi or 2 pi. We are just going to pick 0, so theta will be equal to 0. As we can see that the upper limit of x is 1 and the upper limit of theta is pi over 6, and the lower limit of x is 0 and the lower limit of theta is also 0. This means that the upper limit pi over 6 and lower limit 0, and the expression is x square upon under root of 4 minus x square. Okay, so what we know is that x is equals to 2 sine theta. So this means that x square will be equals to 2 sine theta whole squared, which means in place of x square, we can write 4 sine square theta. So in place of x square, I'm going to write 4 sine square theta. So in place of x square, we have 4 sine square theta upon under root of 4 minus x square, meaning upon under root of 4 minus 4 sine square theta. And in place of dx, we are going to write 2 cos theta multiplied by d theta. In place of dx, we are going to write 2 cos theta multiplied by d theta. So far, we have achieved this thing. So now in the very next step, what I can do is that 4 sine square theta divided by, inside the square root, I can take 4 as common, multiplied by 1 minus sine square theta. And this whole fraction is multiplied by 2 cos theta multiplied by d theta. Okay, and upper limit pi over 6 and the lower limit is 0. All right, so in place of 1 minus sine square theta, we can write the identity cos square theta. Since you have studied the basic identity since P1, that sine square theta plus cos square theta is equivalent to 1. So cos square theta will be equivalent to 1 minus sine square theta. Okay, so this uh, goes like this: 4 sine square theta divided by under root of 4 cos square theta, and this complete fraction is multiplied by 2 cos theta times d theta. Okay, and upper limit is pi over 6 and the lower limit is 0. All right, so now in place of this under root of 4 cos square theta, we can write 2 cos theta. As simple as that. So 4 sine square theta divided by 2 cos theta. This whole fraction is multiplied by 2 cos theta times d theta, and upper limit pi over 6 and the lower limit is 0. Okay, and then we can see that this 2 cos theta and 2 cos theta is cancelled out, and therefore you are left with this thing. Your integrand is only 4 sine square theta now. So 4 sine square theta with respect to theta, with upper limit pi over 6 and the lower limit being 0. Therefore, we have achieved the requirement of part 1 in this way. Okay, so here was a requirement of part 1. So now let's move on to part 2. Okay, I'm going to make a separator over here. So for part 2, what we need to do, we need to find the value of this integral, the exact value of this integral. Okay, we need to integrate this thing, 4 sine square theta with respect to theta, with upper limit pi over 6 and the lower limit 0. So now in order to integrate this, expression, we need to use the trigonometric identities over here. As we can see that for the trigonometric function sine theta, we have a square as well, and this cannot be integrated without using any identity, because we need to convert this into a form, uh, into a standard integration form. Okay, so for that purpose, I'm going to use a trigonometric identity over here, because I need to remove this squaring over here. Okay, the actual issue over here is with this square. This cannot be integrated without using the respective trigonometric identity. Okay, so as we know the fact that cos 2 theta is basically equivalent to 1 minus 2 sine square theta as well. As you already know that in order to express cos 2 theta, you have three forms. And from those three, we have selected that particular form in which sine square theta exists. Okay, so I'm going to say that 2 sine square theta is equivalent to 1 minus cos 2 theta, which essentially means that sine square theta is equivalent to 1 minus cos 2 theta completely over 2. So far, we have achieved this thing. Okay, so this means that 4 is a common term outside. Okay, we can take 4 as common outside. And in place of sine square theta, I'm going to write 1 minus cos 2 theta completely over 2. And this is supposed to be integrated with respect to theta, with upper limit pi over 6 and the lower limit 0. Okay, so this 4 over 2 is simplified as 2. So I can now say that 2 is a constant term outside, and we need to integrate 1 minus cos 2 theta with respect to theta, with upper limit pi over 6 and the lower limit 0. So far we have achieved this thing. Okay, so now 2 is a common term outside, and when this constant term 1 is integrated with respect to theta, so this becomes simply theta, and then we have the subtraction sign. And when cos 2 theta is differentiated, it will give you sine 2 theta divided by 2. Okay, these all basic concepts you must have studied when you have covered the basic concepts of integration. So when cos 2 theta is integrated, it will give you sine 2 theta divided by 2. Okay, and then this whole thing is now integrated. Upper limit pi over 6 and the lower limit is 0. So this means that if I expand this in this step, so 2 theta minus sine 2 theta, we are left with this thing. Upper limit pi over 6 and the lower limit is 0. All right, and now we need to just put the upper limits and lower limits respectively. So 2 pi over 6 minus sine 2 pi over 6 and then bracket close and then subtraction sign 2 times 0 minus sine 2 times 0. All right. So 2 pi over 6 is simplified as pi over 3 and then the value of sine 2 pi over 6. This is supposed to be under root 3 over 2. So pi minus under root 3 over 2 and this is 0 and this is also 0. So the exact value is pi over 3 minus under root 3 over 2. This is supposed to be your final answer. All right. So this was basically the question number 13 of the handout. And the question was October-November 2010, paper 3, variant 2, question number 5. So now let's have a look at another question, which is handout question number 14. Okay. This one is October-November 2010, paper 3, variant 2, the same paper. And this is question number 9. Okay. So it says that we have a curve of y is equals to x cube times ln x. Okay, and its minimum point m, the least ending point is m. Part 1 requirement is to find the exact coordinates of m. Okay, so this essentially means that dy over dx will be kept equal to 0 because at the least ending point of the graph, dy over dx will be equal to 0. Okay, so in part 1, we need to find the exact coordinates of m. So for that purpose, we are going to differentiate the equation of the curve. So y is equals to x cube multiplied by ln x. So this is in the form of u times v. So this means that we are going to use the differentiation using the product rule formula over here. So u is equals to x cube. This means u dash will be equals to 3x square. Okay. And v is equals to ln x. So v dash is equals to 1 upon x. All right, so when equation of the curve is in the form of u times v, meaning y is equals to u times v, so dy over dx is basically uv dash plus vu dash. Dy over dx is equals to uv dash plus vu dash. This formula is also given to you in the booklet as well. So u times v dash, this means x cube multiplied by 1 upon x and then plus when v times u dash is multiplied, so ln x is multiplied by 3x square and this whole thing will be kept equal to 0 because we need to keep dy over dx function equal to 0 over here. Okay, so first I'm going to simplify the equation. Okay, so x cube divided by x is basically x square and then plus 3x square times ln x and this whole thing will be equal to 0. So now what I can do is take x square as common over here. So taking x square as common multiplied by 1 plus 3 ln x. यार ये बल्ब पता नहीं क्यों बंद हो रहा है. Taking x square as common multiplied by 1 plus 3 ln x and this whole thing is equal to 0. All right. So we have achieved a factorized form over here. All right. So when x square is equated with 0, which means x is equal to 0, and we don't need this point over here. Obviously, that x coordinate of m is a positive value which is greater than 0. So this is simply rejected. This is not needed. Okay, not required over here. Okay, so 1 plus 3 ln x will be equated with 0. So 1 is equals to minus 3 ln x. So this means that ln x is equals to 1 divided by minus 3, meaning minus 1 over 3. So x will be equals to e raised to the power of minus 1 over 3. This is the x coordinate of m in an exact form. Okay, so x is equals to e raised to the power of minus 1 over 3 and we need to find the corresponding value of y as well, and for that purpose I'm going to substitute this into the equation of the curve. So y is equals to x cube multiplied by ln x, which means y is equals to e raised to the power of minus 1 over 3 is whole cubed multiplied by ln x, meaning ln e raised to the power of minus 1 over 3. Okay, so Or you can also say that in place of ln x, we can write minus 1 over 3 as well. This is the same thing. Okay, so this means that when e raised to the power of minus 1 over 3 is whole cubed, so this becomes e raised to the power of minus 1. And in place of ln x, we can write minus 1 over 3. So this complete thing will be minus 1 over 3. Okay, so the value of y will be minus 1 over 3 times e raised to the power of minus 1. Therefore, we are going to say that the exact coordinates of point M are e raised to the power of minus 1 over 3, comma, minus 1 over 3 times e raised to the power of minus 1. This is supposed to be our answer. Alright, these are the exact coordinates of point M. E raised to the power of minus 1 over 3, comma, minus 1 over 3 times e raised to the power of minus 1. So this was the working for part 1. So now let's move on to part 2. Part 2 says that find the exact area of the shaded region bounded by the curve, the x-axis, and the line x is equals to 2. Okay, so for that purpose, I'm going to bring this question on the next page. Okay, so it says that we need to find the exact area of the shaded region. All right, so first thing first, we would need to find the value of this x-intercept over here. Okay, so obviously x cube multiplied by ln x will be equated with 0. So when ln x is equated with 0, so x will be equals to e raised to the power of 0, meaning x will be equals to 1. And when x cube is basically equated with 0, so taking cube root on both sides, x will be equal to 0. We don't need this value over here. We are concerned with a positive value which is greater than 0. So x is equals to 1 will be over here. This is basically the x-intercept which we are looking for. Okay, we are not considering the origin over here because we don't need it. Okay, so x is equals to 1 only. This means that we need to integrate x cube multiplied by ln x with respect to x with upper limit 2 and the lower limit 1. All right, so we simply need to use integration by parts over here because one term is algebraic and the other term is logarithmic. Okay, so we need to use the integration by parts formula over here. Okay, so we need to use the late rule, LATE. Okay, meaning L come first, meaning the ln term, and then the algebraic term. Okay, according to the sequence, we need to pick which thing to keep in place of u. Because when the question on integration by parts comes, it is in the form of u times v dash. The integrand is basically in this form u v dash. We need to integrate this thing with respect to x, and when we integrate this, we have the formula uv minus integration of vu dash with respect to x. So basically our purpose is to make u dash simpler. Okay, so in place of u, we are going to keep ln x. So u is equals to ln x. So u dash will be equals to 1 upon x. And in place of v dash, we are going to write x cube. So v will be equals to x raised to the power of 4 over 4. All right. We have to make u dash simpler first thing, and we need to use this particular sequence LATE. I mean, this is basically the sequence to pick, the u term. All right, because we have to make u dash simpler over here. All right. And the questions particularly which involve the inverse trigonometric functions. Okay, so in that case, we use this rule, LIATE rule. I comes after L. The inverse, this I is basically the inverse trigonometric function. But in this particular question, we don't have any inverse trigonometric function involved. So we are going to use the late rule only. All right, so uv minus integration of vu dash with respect to x. This means that x raised to the power of 4 over 4 multiplied by ln x minus integration of x raised to the power of 4 over 4 multiplied by 1 upon x. This will be integrated with respect to x. And here the first part of this expression is integrated, so upper limit 2 and lower limit 1 like this. And this is supposed to be integrated, so upper limit 2 and lower limit 1 like this. Okay, so now in the next step, what I'm going to do, x raised to the power of 4 over 4 multiplied by ln x minus, when x raised to the power of 4 is divided by x, this will give you x cube. And we can also say that minus 1 over 4 is a common term outside, and we need to integrate x cube with respect to x with upper limit 2 and lower limit 1. And this is integrated already, so upper limit 2 and the lower limit 1 like this. So far we have achieved this thing. Okay, so now I'm going to say that x raised to the power of 4 over 4 multiplied by ln x minus 1 over 4 times x raised to the power of 4 over 4, and now everything is integrated, so upper limit 2 and the lower limit 1 like this. So this turns out to be x raised to the power of 4 over 4 multiplied by ln x minus x raised to the power of 4 over 16, upper limit 2 and the lower limit 1 like this. Okay, so far we have achieved this thing, and what we need to do, we need to find the exact area of the shaded region. Okay, so we need to give our answer in an exact form over here. So 2 raised to the power of 4 over 4 multiplied by ln2 minus 2 raised to the power of 4 over 16. This is the upper limit, and then subtraction sign, and then you know we are going to put the lower limit 1 over here, so 1 raised to the power of 4 over 4 multiplied by ln1 minus 1 raised to the power of 4 over 16. Okay, so now I'm going to continue my working after this arrow. Okay, so 2 raised to the power of 4 is 16, 16 over 4 is 4, so 4 ln2 minus 16 over 16 will be 1, and then ln1 is 0, so minus 0, and then plus 1 over 16. Okay, so in your calculator you are going to write 1 over 16 minus 1. Okay, so 1 over 16 and then minus 1, this is supposed to be minus 15 over 16, so 4 ln2 minus 15 over 16. So you can write your answer in any particular form. Okay, so 4 ln2 minus 15 over 16, as long as it is an exact form. Otherwise, you can also say that, this 4 ln2 is basically ln2 raised to the power of 4. So 2 raised to the power of 4 is 16. So you can also write your answer like this, ln 16 minus 15 over 16. So it's also completely fine. Okay, so if you leave your answer in this form, 4 ln2 minus 15 over 16, it's perfectly fine. Unless, the question says that give your answer in the form of ln a minus b over c, where a, b, and c are integers to be found. It is something else. However, in this particular part, the only requirement is to find the exact area of the shaded region. So 4 ln2 minus 15 over 16 is your answer. So this was basically the question number 14 of the handout, October-November 2010, paper 3, variant 2, question number 9. Thanks for watching. Inshallah, I'll be uploading more videos. So stay tuned to my channel and do consider subscribing to it. Thanks for watching. If you have any queries, so you can reach out to me on my WhatsApp number, which is shown over here. So inshallah, see you in my next video. Assalamu alaikum.